Hi everybody, welcome back to chemistry. In this video, we're going to continue talking about section 2.6 in our textbook, and we're going to practice those unit conversions, which now I'm going to start calling unit conversions dimensional analysis problems. So dimensional analysis is another way of saying unit conversions, but it indicates that there might be more than one step. Okay. So this first one, pause the video, try this out on your own, and then check back in. Okay, so it says a rattlesnake is 2.44 meters long. How many centimeters is the snake? Okay, so what are we given? Yeah, we're given that the rattlesnake is 2.44 meters long. Sorry, I don't know why I'm missing that. What do we want to get to? Where do we want to go? Yeah, we want to get to centimeters. So this is our goal. Okay, so let's go ahead and start this problem. So I think I'll use the train track method for now. But again, you can write this in two different ways. So you can do the train track method like I'm doing, or you could write it like this and then just do the next parts like that. Okay, I'm going to do the train track method for now. Okay, so we start with what we're given, 2.44 meters, and we want to get to centimeters. So what's the equality that we know between meters and centimeters? Well, which one is our bigger unit, meters or centimeters? Actually, let's write that over here. What's our bigger unit, meters or centimeters? Yeah, meters are bigger. So let's try to figure out how many centimeters are in 1 meter. So what goes in that box there? Yeah, 100 goes in there. Okay, so 100 centimeters are in 1 meter. You could have also said that 1 centimeter is 0.01 meters. That would have been just fine, or 10 to the minus 2. You could have also put 10 to the positive 2 up here. Okay, but let's go with my original one, and let's do that because I find that easier. So now we can split this up into our conversion factors. So we have 1 meter over 100 centimeters, or we have 100 centimeters over 1 meter. So now it's a matter of figuring out what conversion factor do I want to use right here. If I want to get to centimeters, where does centimeters need to be, on the top or the bottom in my fraction? Yeah, it needs to be on the top. Whatever goes up here on the top is what you're left with at the end of the problem. Okay, I'm actually going to shorten my train tracks a little bit here. So and we also want to cancel out these meters here. We don't want to have meters. We want to get to centimeters. So where do I need to, which one of these conversion factors do I need to use? This one or this one? Yeah, we're going to need this one. Oops. This one. Because meters are on the bottom and centimeters are on the top in that one. So let's go 1 meter and 100 centimeters. Oh, sorry, I didn't really mean to be in blue. 100 cm 1 meter. All right, and now that's going to allow us to cancel out those meters because we see them in the top and the bottom, right? So cancel those out, and then we're left with centimeters, which is what we wanted in the first place, right? So are we done? No, we got to actually carry out the calculation. So the way that works is you're going to multiply everything that's on the top and then divide by everything that's on the bottom. So on the top, we have 2.44 times 100, and we get, whoops, 244. And then you could put divide by 1, but that's just going to give us back 244, so I'm going to leave that. And then we can't forget our units, so centimeters. Okay? That's a big one. You always want to add your units in there. That's the point of this problem, right? We wanted to get to centimeters. Okay, so the next thing we need to do is we need to check for our sig figs. And we need to make sure that we're reporting the right number of sig figs. So where do we have measured values in this dimensional analysis problem? Which one was measured? Which one did we take a measurement of? Yeah, the rattlesnake length, right? So that is a measured value. Someone measured how long that rattlesnake was. Okay, so this one has how many sig figs? Yeah, 3 sig figs. Do we need to measure? Do we need to count sig figs for this conversion factor? No, we don't, right? This is a metric system equality. So this is a defined, oops, I meant to highlight that. This is a defined exact equality. So we don't have to count sig figs for that. So we only have to worry about this one. And that's great because we actually already have 3 sig figs here, right? So that's our final answer. Okay, let's keep going. All right, so you can actually use more than one, 2 or more conversion factors. And what that means is that when you set up your train tracks, you might have several different fractions, right? And these, remember, each of these is a conversion factor. Okay, so, and then you can also set it up like this, right? You could have this times this times this. So either way that works for you. So, and then remember, just real quick, sorry, let's go up here. So remember, each of these are fractions, okay? There's an imaginary 1 down here. So each train track, so to speak, is a fraction, okay? You could have also written it like 2.44 meters times 100 cm over 1 meter. You could have written it like that as well. That means the same thing. Okay? All right, so maybe I'll switch actually, and in this following one, we will do the other type of setup, okay? And then we can see which one you like better. All right, so in this example, I just want to look at this part up here, and I want to ignore this bottom part, okay? Because it's just, there's a lot going on there for me. So let's just look at this part. So a doctor's order prescribed a dosage of 0.150 milligrams of Synthroid. So I'm just writing that down. Okay, so that's what we're given. So let's do given. If tablets contain 75 micrograms of Synthroid, how many tablets are required to provide the prescribed medication? Okay, so it looks like our goal eventually is to get to how many tablets we need. So let's put need number of tablets. Okay. Oops, I'm trying to write. Here we go. Number of tablets. Okay, and then what I'm also noticing is that we have each tablet contains 75 micrograms. So 1 tablet equals 75 micrograms. Do you see how I got there? If each tablet contains 75 micrograms, we can set up an equality that 1 tablet equals 75 micrograms of Synthroid. Okay? All right, so let's think about this for a little bit. I'm going to scooch this over. We are given milligrams of our medicine, Synthroid, and we want to get to tablets. What connects milligrams and tablets in this example? Let's go milligrams to tablets. Can we go directly from milligrams to tablets? No, we can't, because our tablets equality is listed in micrograms. Okay, so we need to actually go through micrograms. So here's what I want to do. I'm going to move tablets over because I know I have a step right in between. So I have milligrams to micrograms to tablets. Okay. Pause the video, think about that if you need to for a little bit. Okay, and then do I have a direct relationship between milligrams and micrograms? No, not really. I mean, I could mathematically solve it, but I always find it easier to go back to my base unit and then go to the next unit. And let me tell you what I mean by that. Let's scooch this over even more. And then let's say I know the conversion factor, I know the equality between my milligrams and grams, right? I have that in my table. And then I also know the equality from grams to micrograms, right? I know how to get from grams to micrograms. I know how to get from milligrams to grams and vice versa. What I don't know is how to get from here to here directly. And you can actually do it using scientific notation, but I never really do that. I find it easier to just write it all out. But you can if you want to. Okay, so this is my general problem solving strategy, okay, for this problem. So let me move this down here. All right. Okay, so let's go ahead and start this problem. And then I'm actually going to make this red, just because this is all the information we're starting with or figured out, right? No, stop. Oh, there we go. Okay, so let's start our dimensional analysis problem. So remember, we're always starting with what we're given. So we were given that 0.150 milligrams of synthroid. Okay. Let me scooch it over again. Sorry, you know I've done a lot of that. And let's set it up like this time. Okay, so 0.150 milligrams of synthroid. Okay, so what goes on the bottom in my fraction? What conversion factor do I have? Remember, my first goal is to get from milligrams to grams. So what goes in the top and what goes in the bottom for units? Yeah, milligrams goes on the bottom because we want to cancel out that unit, right? And let me put synth here just so we know it's what it is. And then what goes in the top? Yeah, grams. Grams are going to go in the top. Okay? So we have milligrams to grams. Now, do we know the numbers that go here? Yeah, we do. So let's go over here. And let's say for this step here, we know that, which one's bigger, grams or milligrams? Yeah, grams are bigger. So 1 gram equals how many milligrams? 1,000, yeah. So the number that goes up here is 1, and down here is 1,000. Okay? All right, now we can cancel out milligrams, milligrams of synthroid. Sorry, you guys, I don't know what's going on with my iPad today. Come on. There we go. All right. Cancel that out, the units, right? And then we're left with grams. We don't want grams. That's not our ultimate goal. Let's actually move this guy down here. Give ourselves a little more room here. All right, so we don't want grams. So what goes next? What's our next step? We want to get rid of those grams. So how are we going to do that? Well, we know another conversion factor. We know another equality between grams and micrograms. What's our bigger unit, grams or micrograms? Grams are still bigger, so 1 gram equals, how many micrograms are in a gram? 10 to the 6 micrograms. You could also think of it as a million, right? So 1,000,000 micrograms are in 1 gram. And I got that from my table, okay, my metric system table. All right, so grams. Does grams go in the top or the bottom? Yeah, grams goes in the bottom. If you put grams on the top, right? Say you were like, oh, let's put it in the top. What is grams times grams? Well, grams times grams is actually grams squared, right? Because remember, whenever you have exponents that you're multiplying, you add them up here. So if you're multiplying these numbers, I should say, and they each have exponents, you're going to add the exponents. So grams times grams equals grams squared. Okay, so we don't want grams in the top because we're not looking for grams squared. I don't have grams squared anywhere in my dimension, in my plan here. So grams has got to go in the bottom because we want to cancel it out. Okay, so grams goes in the bottom, so what goes in the top? Micrograms. Okay, how many micrograms? Let's write this 10 to the 6 also, and let's do 10 to the 6 up here is 1 gram, right? I just wrote a million in a different way, 10 to the 6, just to shorten things a little bit. All right, well, great. Now we can cancel out those grams because we find them in the top and the bottom. And are we done? No, darn it, we're still not done because we need to know this part. How many micrograms gives us how many tablets? All right, so we got one more of these. Let's do this. So what goes on the top and what goes on the bottom? Tablets or micrograms? Micrograms goes on the bottom. Tablets goes on the top. What's our conversion factor? What numbers do we put there? Yeah, we were given this equality. So 75 micrograms equals 1 tablet. I know you guys, hang in there with me. All right, and now we can cancel out those micrograms, right? And get 2 tablets, which is our final goal, right? We wanted to end up in tablets. So let's look here in a different color. We had this step was going from milligrams to grams. This step was going from grams to micrograms. And this step was going from micrograms to tablets. All right. Let's clean this up just a little bit so we can see better. And now it's all a matter of carrying out the calculation. Okay, so equals, I'm going to put an equal sign here. Now, the way I do it is I multiply everything on the top and then divide by everything on the bottom. Okay, notice now we have some numbers on the bottom. Okay, so you could multiply this fraction by this fraction, get an answer, then multiply this fraction by this fraction, get an answer, right? I just prefer to do it all in one go. So let's do this. We have 0.150 times 1 times 10 to the 6th. Whoops, I messed that up in my calculator. Hold on. Delete 10 to the 6th. Okay. Times 1. So that number is 15,000. 15, let's go ahead and write that down. 15,000. Oh, no, it's not. It's 150,000. Sorry. 150,000. 150,000 what? Tablets is still on the top. Divided by everything that's on the bottom. So I am multiplying everything on the bottom as well. So 1,000 times 75 is 75,000. 75,000. And I don't have any units on the bottom anymore, right? Okay. Gosh, that's a long one. Let's scooch out a little. Okay, so now we can actually divide these numbers. So we got 15,000, or 150,000, divided by 75,000. And that gives us 2. Two tablets. All right, let's think about this here. So, are we done? Are we done? Is this number that we've reported correct? Well, the number is correct, but do we have the right amount of sig figs? So looking over here, how many sig figs are in our measured value there? Let's go green again. Yeah, that one has 3 sig figs. Okay. What about these ones? Do we need to worry about sig figs for these? No, they're just metric system ones, right? So they're exact numbers. And then what about here? Micrograms per tablet. Is that one a measured value or an exact value? That one's a measured value. So let's go ahead and say, right, because someone measured that there were 75 micrograms in one tablet. Okay, so let's say that has 2 sig figs. So how many, remember, we're just multiplying and dividing in this problem. We haven't added or subtracted. So how many sig figs should you have in your final answer? 2. So this is one of those occasions where your calculator actually spits out just this digit. But that's actually, we need to add a 0 in there because we actually are more sure of that number. So let's scooch that over and we'll put, remember, 0.0 in there. You can add those zeros, just put that decimal place there. Okay, so now this would be our final answer. All right, I hope that that makes sense. Okay, so how many minutes? Let's move on to the next one. How many minutes are in 1.4 days? Okay, so 1.4 days. So this is what we're given, right? And this is what we want to get to. Need. Okay, so pause the video, try it out on your own. All right, let's do this. 1.4 days. All right, 1.4 days. That's what we're given. So I'm going to start off my train tracks with 1.4 days. Where do we want to get to? We want to get to minutes. Okay, I don't know exactly how many minutes are in a day. You might know that. Some people just like carry around those types of facts with them, which is really fascinating. I don't know that. So for me, I want to go from days, I think, to hours to minutes. Okay, that's what I would think. That's how I think. Okay, because I know how many hours are in a day. So 1 day equals how many hours? Yeah, 24 hours. Is that an exact value or a measured one? That's exact. It's an exact number. We've decided that a day is 24 hours. Okay? And then how many minutes are in an hour? Yeah, 60 minutes. 60 minutes. Okay, so we have our conversion factors here, right? We have this and this. And we can connect those things. So we have days on the top, right here. What do we want on the bottom in our next train track? Days, because we want to cancel out days and get to minutes. So 1 day equals, what goes up here? You're going to put minutes up there? No, I don't have a conversion factor that links minutes and days. You might, but I don't in this problem here. I didn't calculate that. So I have 1 day, or I guess I should have left that 1 day, equals how many hours? 24 hours. Okay, and now we can cancel out those days, and we're left with hours. Are we done? No, we wanted to get to minutes. So let's do our next train track, and that's going to be, what goes on the bottom? This or this? Hours. Yeah, we want to cancel out hours. So 1 hour equals how many minutes? 60 minutes. And then we can cancel out hours. Okay, so now we're left with 1.4 times 24 times 60. So in the numerator, we're looking at 2016. Oh, and then in the denominator, we just have 1 and 1. So 1 times 1 is just 1. So I don't know why that wrote so thick. Let's do this again. 2016 minutes, right? Because we're left with minutes in the numerator. Okay. Oh, we forgot to do our sig. I knew I was forgetting something. We need to do our sig figs. Okay, so bad, Kayla. All right, so we have how many sig figs in, oops, in our 1.4 days? That's a measured value, right? So we got to report sig figs. So how many sig figs there? Two sig figs. Okay, these are not measured values, right? Those are exact. So exact and exact. Okay, so how many sig figs should we have in our final answer? We should have 2. Do we have 2 here? No, we actually have 4. So this is interesting. And we haven't gone over this yet, so if it doesn't immediately jump out at you, that's totally fine. So we have 2016 minutes, but we actually aren't sure of, we need just 2 sig figs. So what you can do is you can actually round this to 2000 mins. Okay, because the only way we're going to get 2 sig figs out of this number, but still have a number that's close, is to make these zeros. Okay, and now we actually, if you look at this, we actually only have 1 sig fig in this number. So let's actually report it as, and this is weird, it's really weird. This is kind of a weird example. I don't think I would give you this on an exam, but let's convert this to scientific notation, because remember, with scientific notation, we can make it so that we have as many sig figs here as we want, right? So we know we'll have something times 10 to something. So let's do this, and this is really weird. 1, 2, and 3, getting our number between 2 and 10, or 1 and 10. Okay, so now what goes here is 2.000 times 10 to the, what did we move this over? We moved it over 3. Okay, but again, this is too many sig figs. So what can we do? Yeah, we can actually just get rid of those zeros. Because why? Because they're just placeholder, right? You could write this 2.00000. You could write it 2.00000, whatever. So we can get rid of those zeros and manipulate that so that we just have the 2 sig figs. Again, this is a little bit of a weird example. I probably wouldn't give you something like this on a test where you had to do all this gymnastics with sig figs, but I will have you like check for correct sig figs. Okay, all right, so let's keep moving along here. How many more of these do we have? All right, that's our last one. We can do it. I know this video is getting kind of long again. Okay, so if your pace on a treadmill is 65 meters per minute, how many minutes will it take for you to walk a distance of 7.5 kilometers? A lot going on here. Pause the video, think about it, try it out on your own, okay? You can get it wrong, right? Right now is the best time to get it wrong because you're not actually being graded. Take a sip of my coffee. Okay, if your pace on a treadmill is 65 meters per minute, all right, well, so let's go ahead and write down that conversion factor. 65 meters equals 1 min, right? 65 meters per minute is the same thing as saying this equality here. All right, how many minutes will it take for you to walk a distance of 7.5 kilometers? So 7.5 kilometers equals question mark mins. This one's a little weird because you're kind of given a lot more information than we maybe have been in previous examples. So my question to you is this: what goes in my first train track? What goes right here? And let me actually make it so it looks like that. What goes in my first train track? Yeah, if you answered 7.5 kilometers, you'd be correct. And let me show you why. The reason I'm starting out with that is that my goal is to figure out how many minutes. So the way that this is going to work is we've got to go from kilometers to what? Mins would be my ultimate goal. Do I have a conversion factor between kilometers and mins? Minutes, I guess I should say. No, I don't. But I do have something connecting meters and minutes. So what if we go from kilometers to meters, right? We know that conversion factor. So then we can get from here to here, and then to mins, right? So 2 minutes. Yeah. Okay, I don't know why I keep wanting to change this line here. Okay. All right, so kilometers, my general idea is to go from kilometers to meters, and then meters to minutes. Okay, so I have kilometers. How am I going to get to meters from kilometers? Well, I need to know the equality for that. So what's my bigger unit, kilometers or meters? Yep, kilometers are bigger. So let's figure out how many meters we have in 1 kilometer. How many meters do we have in 1 kilometer? 1,000, right? Okay, so do we have 1 kilometer in the bottom or in the top? Do we put kilometers in the bottom or top? Bottom. We got to cancel them out, right? How many kilometers? 1 and 1,000 meters. All right, now we're done with kilometers. Yay. And we're in meters. Great. Because I have something that connects meters to minutes. Okay. So what goes in the bottom? 65 meters or 1 minute? 65 meters. Yeah, we want to get rid of those meters. All right, get rid of that, get rid of that. And now we're in minutes. Is that what we wanted? Yeah, we wanted to know how many minutes it would take us to go 75 kilometers. Okay, so let's go ahead and carry out the calculation. Remember, we're multiplying. These are each our fractions. So we're multiplying everything on the top and then dividing by everything that's on the bottom. So 7.5 times 1,000 times 1 is 75,000. Sorry, 7,500. And then what's our unit? Minutes, right? That was the whole reason we did this. And then we still have stuff in the bottom. So 1 times 65 is just 65. Okay. So 7,500 divided by 65. Oh, sorry, I didn't mean to put minutes there. Because then it would cancel out, right? Is 115.3846154 minutes. Okay. Let's go ahead and round this. How are we going to round it? So our measured value is 7.5 kilometers. Okay, so how many sig figs are in that? Let's go green. We got 2 sig figs there. Okay. And then what other measured value do we have? Yeah, this is also a measured value. Because we're measuring, we can go 65 meters in 1 minute. There's some error in there. This, however, is not a measured value, right? That's just a conversion. It's our exact conversion between meters and kilometers. We know that. All right, so how many sig figs should I have in my final answer? 2. How are we going to get this to 2 sig figs? Yeah, it's a little bit weird. We're going to have to do kind of gymnastics. So let's see how they did it down here. Yeah, so they basically just rounded to 120. I was going to see if they did it in scientific notation. And you could, but it would just be just as easy to just round this to 120. So because 115 is so close to 120, you're just going to have to do some rounding. And I know that feels annoying because we have this really beautiful number over here with a bunch of different decimal places, but we can only be sure of 2 of those sig figs. So we got to round up. And how many sig figs are in 120? 2. Okay. I hope that makes sense. Let me know if you have any questions, and I'll see you in a little bit to talk about density.